Welcome everyone to this webinar. We're going to be talking about fraud detection using Oracle Machine Learning. Hi, my name is Charlie Berger. I'm the Senior Director of Product Management for Machine Learning at Oracle, and I'm joined today by Do-Hoon Kim, with whom I've been working with for a while, doing what I hope is a good and an informative session on using our products together. The way this is going to work is I'm going to do some of the introductions and do a little bit of the demo. I'm going to turn it over to Do-Hoon, who's going to do a little bit of a demo, and he's going to turn it back to me, and we're going to kind of go back and forth. And in about 45 minutes from now, we will hopefully have shared with you, some interesting material here. So here we go. This is going to be a two-step process for detecting fraud. We're going to use the Oracle Autonomous Database. We're going to use Oracle Machine Learning that comes with the Autonomous Database, Oracle Application Express, and Oracle Analytics Cloud as well. So we're going to put together a number of different pieces and solve a problem and sort of automate it along the way. And the way that we make this a lot easier is by Oracle's strategy of moving the algorithms, not the data. And you've probably heard Oracle's strategy about the converged database. And the converged database is kind of exciting because it has so many features and functions, sort of a Swiss Army knife of capabilities inside this one, capable converged database. And we'll show you how we're leveraging just a few of those features for a nice solution. If you need to follow up with either one of us, myself or Do-Hoon, we've put our emails there and our Twitter and so on. So feel free to reach out to us. Now, I said this is a two-step process because what we're going to do is we're going to first use an unsupervised Oracle machine learning algorithm. Specifically, we're going to use something called a one-class support vector machine to flag the anomalous insurance claims. We do that by training on what we call normal records and then applying that sense of normal records to a new set of data and flagging those records that are on a multi-dimensional, or sort of multi-peculiar. They stand out in some way. Then what we're going to do is we're going to use, and this is where Do-Hoon's going to step in, and he's going to show an Apex application that he built that we're going to say it's a simple. You can do more than this, but it's a fairly straightforward application, but very useful, very powerful. And the idea here is the claims investigators are going to be able to focus on the most suspicious claims. So I'm going to use machine learning in an unsupervised way to flag those records that stand out as being the most sort of something's going on here. Do-Hoon's going to come in with his application express use case and walk through those and kind of review them and check out the predictions that I've generated, use his own domain expertise, the insurance claims adjusters expertise to investigate the claims, and they're going to rule on whether or not these claims are considered to be fraudulent or not. So Do-Hoon's going to come in here and be the human that's going to add into the machine learning capabilities. Then for step two, now that we've built now what we have what we call a bunch of labeled data for which we know what the answers are. We know these are fraudulent and these are not fraudulent. We can build a supervised learning machine learning model inside the Autonomous Database using Oracle Machine Learning, and we're going to do that. Then we're going to come back, and Do-Hoon's going to show us some more with Oracle Application Express about how we can now do more dashboards and more investigation of it. And then I'm going to come back in and show how we can do even more with the Oracle Analytics Cloud, and this whole process can just be automated inside the database. So that's it. It's a two-step process that actually has a few different steps, but from a machine learning point of view, it's going to be unsupervised learning first and then supervised learning. Now, I always like to start out and say, what is machine learning? Because a lot of people, are new to this. Some people, forgive me for those who know this very, very well, but, machine learning is trying to find patterns in data, and typically it's labeled data. In this case, we have people who churn and people who are loyal customers. And if we try to fit a straight line through that data, we might do an okay job, but not so good of a fit, right? If we had more of a curvature to our model, a polynomial or something, we might do a better job using traditional statistical techniques. But if you use a machine learning algorithm, in this case a decision tree, it finds these curves in the data, finds these little sort of cut points and finds, aha, there's a significant difference in the patterns here when I have customer months above a certain threshold and where income's above a certain threshold. And the nice thing about these supervised learning models, and specifically a decision tree, is they provide reasons, that it's very clear what's going on. They can provide human readable rules and so on, and they can tell you what the size of the segment is and what's going on, because there's a lot of data, and that's what it does. It sifts through and finds these patterns. Now, we're also going to be able to provide rules later on. I'll show you that. It's called prediction details, but the problem gets a lot harder, so we provide predictions and insights. The problem gets a lot harder when you have very, very few examples for the algorithms to train on, right? If I only have 1 or 2 data points, it's hard for me to draw a line through that, through what we're saying is suspicious or fraudulent behavior and normal behavior. It's just, it's not so easily done, right? So what we're going to do over here is we're going to do something a little bit different. We're going to try and find the needles in the haystack by looking or training on the normal records. And we use, if you think of your brain, how that works, that's kind of what we're going to do here. So it's a tough problem, but we're going to use a different approach. Now, hopefully all of you remember this fellow Waldo, and there was a lot of children's books. I still read them. They're great books. Where is Waldo? Where's Waldo? And typically what happens is there's a beach scene or a big shopping mall or a fair or something, and it's very busy, very, very crowded. There's lots of data, as we would say, out there, and you are trying to, you're being asked to find Waldo. So we're going to kind of play that game right now. Can you find Waldo in 10 seconds? So I'm going to give you a little bit of time here, and can you find Waldo in the crowd? And we're going to think about how your brain works. This is why we're doing this. So ready, set, go. 3, 2, 1, time's up. Okay, did you find Waldo? Well, there he is. Now, how do you find Waldo in a crowd like this? Well, let's think about how your brain works. Your brain works to find what's different. So I'm looking for like this little hat. I'm looking typically for these stripes. I might see some stripes over here with this lady, but that's not Waldo. Might see some more stripes over here on this guy. That's not Waldo. So I'm looking for those things that sort of stand out as being different from the rest of the training population. And that's the way the one class support vector machine algorithm that comes inside the Oracle database as part of the Oracle machine learning feature of the database, that's how it works. So we're going to do that as part of our demo. But first, I'm going to give you a real quick overview of what Oracle machine learning is. So Oracle machine learning is a free feature of the database. It became free in December 5th, 2019, along with Oracle Spatial and Oracle Graph. And it extends the database and enables users to build AI, whatever you mean by, air quotes AI, applications and analytic dashboards. It delivers over 30 powerful in-database machine learning algorithms and automated machine learning functionality. We even have something called AutoML that's coming very, very soon, but we also have many other automatic data preparation features and so on. And depending on what, whether you're on-prem or in the cloud, we're going to have different sort of user interfaces. We're going to have the notebooks that we're going to use up on the Autonomous Database Cloud. There's also this drag and drop GUI that's part of SQL Developer. We integrate with R, and very shortly we'll be integrating with Python, so you can use Python or R. The Python will come up in the cloud initially, and then we have a new user interface, Oracle AutoML user interface, that'll also come up on the Autonomous platform. But we have different sort of touch points or user interfaces to this functionality. But the key is, we brought all the algorithms to the database. Why? Because that's where the data is. That's where we're going to try and find these patterns like fraud. And what we're trying to do is make machine learning simple. So now you can embed that in Fusion applications, or the Oracle Analytics Cloud is already integrated with us. And we've also integrated with a number of different applications. So that's kind of an overview of it. And as I've said before, it's free. If you have an Oracle database now, you have these features and these algorithms, and you can use them. And Do-Hoon and I are going to try and show you how to do that. So I also just want to go on a little bit of a tangent here to just talk about the contrasting architectures between Oracle's converged database architecture and what you would ordinarily be doing today to solve these kind of problems. Oracle has this simpler, more integrated architecture. It's dramatically simpler for developers to invoke declarative SQL. We also have support Python and R to run the algorithms, but we also have support for spatial, graph, JSON, unstructured, and so on, all in this sort of Swiss Army knife converged database. Otherwise, you're using a lot of parts, right? And you're having this part talk to that part, move the data over here, move the data over there, deploy a model out on some VM or Docker, and it's admittedly, a little bit more complicated. Ours is all running in a safe, secure, parallelized, scalable, backed up, audited, encrypted, converged database, which is kind of nice. In terms of the algorithms that we have at our disposal here, there's over 30 of them, and it's always growing. In the next release of the database, we're adding support for XGBoost and also this MSET SPRT for process anomaly detection. But today we're going to mostly be using the anomaly detection, the one class support vector machine, and we're going to use some of the classification models. After Do-Hoon gives us the labeled data, we're going to come back and use the supervised learning. But the nice thing I always like to point out about this is they are part of the database. So if you want to use SQL functions, or you can use the SQL API to do this. If you want to build a model and partition by region. You can do that. If you want to use transactional data, you can use aggregations to add up all the different transactions, or use unstructured data. I always joke that, you know, marital status is a paragraph, not a, you know, single, married, divorced, or that kind of thing. If you have geospatial data, graph data, and you can imagine having a lot of geospatial and graph data in a fraud model. Now, right now we're doing something a little bit simpler than that, but you can do a lot of different things here using these, you know, 30+ analytical power tool algorithms that come embedded in every Oracle database now. And as I said before, depending on whether or not you're on-prem, you see this little sort of gray line right here, you can use the RStudio or drag and drop Oracle Data Miner. It comes with SQL Developer. We're going to be doing stuff up on the cloud using the notebooks. We're going to be using the 100% SQL version because we don't quite have access to the Python version. That's coming in very, very shortly as we record this in early or mid-November in 2020. So that'll be coming out very, very shortly. But we're going to do it all up in the cloud, and we're going to use the notebooks. So we're using Oracle Machine Learning. You can see that we've kind of showing this auto insurance claims fraud notebook that we have over here. And it's a collaborative user interface. So Dohoon and I have been building these models in the notebook. He does some work, I do some work. We update it. It's a sort of shared environment. And it comes packaged with the Autonmous Database. I'll show you that in a second. We have 9 example notebooks. We took the anomaly detection notebook and sort of modified it a little bit and pointed at our own data and so on. The Python version will be coming very, very soon, where some of these paragraphs right here, I could just say %Python and start typing in Python code, and I could, you know, talk to the same in-database SQL functions, or use scikit-learn or matplotlib or various pre-installed Python packages. So that's kind of the environment that we're going to be in. As I've said, we're using one of the example notebooks, the anomaly detection notebook, and we've just opened this up, saved it, edited it, and made it our own. Under the hood, this is kind of what's going on, right? I am using this begin DBMS data mining create model syntax to say I'm going to do a claims model. The data table that we're going to be mining here is claims. Policy number is the unique identifier. It's a classification type of problem, but the target column is null, right? We don't have a target field. We don't have any example of previous fraud. We're doing unsupervised learning here. Now, there's another way to do this claims create model 2 that says I'm going to take some of these settings and kind of nest them in line in the syntax here. There's 2 different ways of doing that, and I'm showing the original claims data create model regular. There's also a claim create model 2 version of this. Once we've built the model, we can use the model and score it on the fly. And as I've shown over here, I'm showing what are the top 5 most suspicious claims. I could schedule that to be something that runs every week, every month, whatever. And Dohoon's going to show how he's taken these results and put them in a more interesting kind of dashboard using Oracle Application Express. So here we go into the first stage of this. There's 2 steps. The auto claims fraud using unsupervised learning. We're going to go into this notebook. Now, I've got backup screenshots here that kind of explain what's going on, but I'll come back and show those just to summarize. But right now, I'm going to go over to the live software, assuming everything's working here. And I'm going to go over to my instance of Oracle Machine Learning. Now, Oracle Machine Learning comes with the Autonmous Database. If you don't know how to get here, you can just Google it. I've put out a YouTube video out there, Oracle Machine Learning getting started. You can go to any Oracle Autonmous Database thing, you can see what's going on. But there are different, you go to the home here, you have notebooks, you have previous notebooks that I've run. You can see what we've been doing in here. I'm going to go back to the notebooks. There are example notebooks. I'm going to skip over some of this, and I'm going to come into here to the unsupervised learning notebook, the one I just had there. So sometimes it may take just a little bit, a moment for it to load the notebook. It's running up a Zeppelin VM as it kind of wakes up the notebook and brings it to us to use. And then I've already run this notebook. I might just set it off to run again here, but I've already run it. Just ran it earlier today on November 13th. And you can see that we have a little bit of preamble about what's going on, about how many people commit fraud, and this notebook shows how to flag anomalous records. I can put a cute little picture in here, and I can also change the width of these spaces. I've got this a 4, and this one over here is an 8, and they sort of add up, and I can lay these things out. I'm talking about the business problem, and what I'm going to do here is just set this whole thing to run just kind of while I'm talking through this. And it's going to cascade through the notebook and run all the different steps, as you can kind of see it doing right now. And I can also kind of explain this to you as it's walking through the logic. So I'm just going to kind of show you what we did here. So first of all, we're trying to sift through a lot of automobile insurance claims. So we have this claims 0. The claims 0 data set is distinguished from the claims data set because this is the unlabeled data. There's no column here that says whether or not things are fraudulent or not. We just have a bunch of data about claims that have come in. And we're not doing with any, we're not dealing with any kind of a, stop clicking around here while I'm doing this. We're not dealing with any kind of unstructured data or transactional data or anything like that. We're just kind of walking through a nice, well-behaved two-dimensional data set. Now, the first thing I may want to do is look at some of the data. I can look at this as both a table. I can look at it as a graph, and I've set this up, and you can go into the settings here, and you can set up how you want this to set up. So there's a lot of little sort of things that happen in the notebooks, how to do that. I've done it again over here. I'm just trying to see if I can find, you know, most accidents reported are in their, the people involved are in their 30s and 40s, and they have a $400 deductible. So, and most of them are, I guess, unfortunately for you and I, Dohon, they're mostly males. It looks like they're having most of the accidents, and they're happening on Fridays and Mondays. And so I can go through this and maybe find the root cause of what's going on here. But chances are I'm not going to, right? Because if it were that easy, we wouldn't be needing machine learning here. So we display a few different graphs and tables, and then we come down here to the part where we're going to start doing some machine learning. So we have this notion of there's the business problem. We're going to now set up our claims. We're going to do an support vector machine. And this is where we're doing the brunt of the work, okay, that I showed you before. Begin DBMS data mining, create model. The target field is going to be null. The unique identifier is there. It's a classification type of problem. I've just set up this settings table again. There is another way of doing this called create model too, and that's shown in many other different notebook examples. You have your choice of either way of doing that. And I just run this, and this just ran, well, it's 5:30 now, it just ran now. And look, it took 3 seconds. Kind of quick, right? There's 15,000 records and about 25 variables. Once I've done that, I can take and just sort of run this thing and say display all the customers who are likely to have a problem. I have the percent likelihood of them being anomalous because I have this little 0 here. So 0 means they're anomalous. So I've flagged these guys, and I'm going to hand these over to Dohun. I'm not actually going to hand them over to him. I'm going to leave them in the database. Okay, so he just comes in and points to the same output table, which I think we're calling suspicious claims as we go down here a little bit further. So we have some graphing of this, display the suspicious claims by age of the policy holder, some other different ways of showing the data here. We show the top 5 most suspicious claims by just simply applying this claims model, finding the target field equals 0 using all the input data sets. And we display them in descending order. We maybe do some other graphing or reporting, whatever we want to do. For repeatability purpose of the notebook, I'm going to drop the previous table. I'm going to run it again. I'm going to create that table, and I'm going to say, well, here's the table in the notebook, and I flagged those claims that I think are the most suspicious, but this is just a triage, right? So now I'm going to turn it over to Dohun, who's going to show us how to take it to the next level using other parts of this converged database, Oracle Application Express. So Dohun, are you out there? Are you all ready to go?
Yes, I am. I'm ready. And thank you so much, Charlie, for explaining all machine learning stuff here.
Right.
And let me share my screen and show you some of the what AP can do in machine learning stuff as well. So here, this is the application that I made using the APAC. And here, I didn't import any data, but just using the data set in the Oracle database, I was easily able to make this application in a quick second. And here, when I go to the suspicious claim chart, this is the chart displaying who is most likely on the fraud run and not, based on the policies here. And also here we can make a very interactive one. So for instance, if you want to see the vehicle category and by the past number of claims, let's say we want to choose 2 to 4. This is the what we see here. Also, what is more interesting here is that this is the table showing the what's inside of data here. And so here, based on what we selected on the filter column on the left side, we can see prediction 1 and probability is 0.52, which means it's not necessarily correlated to they are going to be identified as a fraudulent. But here they kind of give us some of the hint that the name, attribute name is the week of the claim, and also day of the week. And also we can see that some of the attributes that was included was a deductible value was equal to 400. So this is the what API can do and how Oracle Machine Learning can implement it in a production.
I'm on mute. Tohun, that's very nice and very clever and cool. I like that quite a bit. And I like the name of your insurance company there, Gecko Insurance. Now with Apex, you could also make this a mobile app of some sort. If I wanted to have this thing run off my Droid or some of that or other different things, Apex supports those kind of things.
Yes, definitely. It can also used on the mobile devices. So for instance, if you are the insurance investigator and if you want to go out there and make the claim form, this can be converted into the mobile form and you can create your own form here and you can type your policy number. So for instance, we can just type in numbers here and select the deductible from the selection here and choose your vehicle model make here and choose the category and here pretty much witness present to no, police reported yes, and so on. And also here you can kind of edit your own information whether you think it's fraudulent or not. So if I do it, it's going to create the form and put them in the database.
Nice, nice. And so so these ones here are the ones that I gave you with the suspicious claims, and you as the insurance investigator can go in here and review each one and officially confirm it, whether or not fraud was found or not, and provide me back some more better curated labeled data then.
Yes, definitely, Charlie.
Cool. Do you have anything else you want to show, or we're going to come back and see the rest of it in a little bit?
Yeah, we're going to come back and see what API can do in the rest of the section later on.
Cool. All right, back to me then. I am going to share my screen and share. And I've got my new Supervised Learning notebook open here, but I just realized I usually like to make sure I'm tracking on the PowerPoint here. So this is the Unsupervised Learning where we went through this, and with the input variables, we did Unsupervised Learning, we did the data understanding, and I show this because we're going to have the slides out there on the blog posting. That's where we built our Unsupervised Learning model, very straightforward, and that's where we left the table on the data in the database to then have Do-Hoon come in and curate these things and actually assign his dispositions, or the insurance adjuster's dispositions. Now, in fact, this is the PowerPoint version of what we just saw. So this is the application. This is what Do-Hoon just showed. The predictions and the probability is very, very nicely done, Do-Hoon. And then you can go in here and edit as he just showed you. And I'm showing this because these are in the slides. You'll see this afterwards. So now, part two. Part two means I've identified the ones we think are kind of suspicious. Do-Hoon's reviewed them all, and he's labeled them. This is suspicious. This is suspicious. This is fraudulent. This is fraudulent. We've got to go after these people, and those ones that are not. And so I am going to hide my floating meetings control here, and then go into part two. Now we're going to do supervised learning. So the idea here is, if you know what you're looking for, fraudulent claims, and you have a lot of examples, and normal claims, it's a lot easier. And if you can boil the problem down to a supervised learning problem with labeled data, then that's what you want to do. And that's what we've done here. So I'm just going to go back and show you how we do that live in Oracle Machine Learning. So while Do-Hoon was doing his part of the demo, I just ran this other notebook here, and you can see it just ran a minute or two ago, and we saw the same problem, except now it's labeled data. So it's a little bit different. And we see the same data, but now we have this field called FraudFound Yes or No. So now we come down here to our data understanding, our bar charts, our visualizations, same kind of thing that we did before. Now we're doing the data preparation. And here, we're going to do this splitting of the data. Now, there's 2 or 3 different ways you can do this. There's actually a setting in the Oracle Machine Learning create model that you can say, I want to have it split the data on the fly, if you will. We're going to do it very explicitly because this is what people are sort of comfortable with oftentimes. And I'm going to create a set of data that's going to be a 60% set of data and for training, and then I'm going to have a holdout sample for the other set of data. And if the code looks a little bit intimidating to you, we're coming with Python. Very shortly, you can do the same thing. If Python code doesn't make you feel any better, you just want a nice GUI, a graphical user interface, that's called Oracle AutoML, and that'll be like 3 clicks to a model. Just click, click, bang, you're done. And that'll be coming, in the coming weeks. I'll just say, around the holidays, let's say it that way. And so here I have a template that I've used that I can use, and it's pretty straightforward. So I'm using the template here, and then now I go to the model building. So I am going to first do the attribute importance. Why? Because it's a supervised learning problem, right? So I can say for the target field equals fraudulent yes or no. Here it is, fraud found is my target field. It's not null, it's target field. You know, it's fraud found. Then build me a model, and here they are. And I can also look at this over as a table if I want, and we can graph that table, we can visualize it, put it in a graph, put it in a pie chart, whatever we want to do. But now that I know these are the key variables, and remember this base policy, some of these, because Do-Hoon's going to key off this later on as he comes back and shows more with Oracle Application Express. And I'll show a little bit of that with Oracle Analytics Cloud as well. So which model to build? I don't know. Let's build them all. Let's build a lot of them. So I didn't build every classification model we can support because we support several. I just did it with a random forest, a generalized linear model, support vector machine, and a decision tree. I could have done a naive Bayes. I could very shortly do an XG boost. And notice they're all the same, right? Random forest, linear model, generalized linear model, that is, support vector machine. All the rest of this is sort of the same syntax. And look at it, it's building the models in 2 seconds, 3 seconds, very, very fast. And then once I've built all those models, well, I want to evaluate them. So now I have my holdout sample, and I test it, and I do a compute the lift. I use it on the training, the testing data set here, and I evaluate, and then I join these all together here with some little clever SQL code here. Derek Cameron gave me that, so shout out to Derek Cameron. But he kind of joins all these things together, cumulative gains chart. So now we can see which, and they're all the models are really pretty good. So we can see which is the best, but they're all pretty good models here, which is a good sign. And we did all this evaluation, each of these things 1 or 2 seconds to do. So now we've got a pretty good model. I forget which model I chose. I guess I chose the generalized linear model because they were all close, and a lot of people are comfortable with GLM models. They've been around for a long time, and we're going to have ridge regression. We're going to have feature generation, all sorts of standard, well understood machine learning algorithm behavior there. And then we're just going to show what are the claims that stand out the most. And so I've done that. But remember, we're leaving all the data in the database so we can come back, use the right tool for the right job. And we've done our machine learning, use Oracle machine learning. That's probably the right tool there. But when it comes down to visualizations, we're going to only be able to go so far with a notebook, and we're going to kind of wish we had some other different tech tools and techniques. So just like the other one, I ran off here and said, okay, use the generalized linear model, target the value of yes, likely to be fraudulent, and I am going to say, view the claim, the suspicious claims table. Now that we've updated this with things that we, using a supervised learning technique, think are fraudulent, and I'm going to say back over to you, Do-Hoon, to show us what you can do with this data using more of Application Express.
Yeah, definitely. So APEC Express can be also used to visualize the data. And as Charlie also showed us in the previous slide, we can also do visualization. But here, pretty much we can see what are the key factors in determining auto insurance claim fraudulent. And here we can see that the base policy is biggest factor contributing to the fraudulent, followed by vehicle category, fault, and past number of claims. And also here we can see that fraudulent by type of the policies. So as we can see, the liability has the most no, but in here in collision case, we have most yes of the fraudulent. And also not only even that, we can also see the a box plot of the fraudulent by the vehicle category. So here we can say that the sedan is the most likely to be claimed as a fraudulent, and followed by sports and utility and so on. And here we can also see the outliers. And here we can also see fraudulent insurance by claim by fault. So in the case that it is the fault of the policyholder, it is more likely filed as a fraudulent. And here, let's moving on to the fraudulent by the past number of the claims. So if we have any numbers, like surprisingly, like anyone who never filed the claim before are more likely claim the fraudulent auto insurance claim. So this is what APEC can do. And yeah, anything that you want to add on, Charlie?
No, except I love box plots. That's my favorite graph of all kinds. And just we said the data that we have is kind of simplistic. We don't have at least we're not showing we don't have it so we could show a map, but with Apex, you can do maps too, right?
Yeah, definitely. You can do maps as well.
You can do all sorts of cool things, and the cool thing about Apex is it comes free. I mean, they're using this in so many different use cases these days. It's just a free feature. I guess it's one of the most popular features of the database. But for a machine learning guy, it's new, you know, and it just comes right with the database, so it makes for a perfect sort of deployment thing. Now, I think it's going to go back to me, and I'm going to show Analytics Cloud.
Yes, definitely.
Okay. Okay. Very good. So I'm going to share my screen. I'm going to go back to here. And so Analytics Cloud, I'm going to come back to this just a second. Like I said, I always like to kind of just go through the PowerPoints and make sure we have our sort of anchor here of what we're doing. So we just came back to the supervised learning. We did the business problem. We did our data understanding. Again, this is for, you know, sort of comprehension. This will be out in the, I'm going to remove the floating controls here again, hide floating controls. So this will be out there as sort of a reference to what you're seeing. I'll add this to the blog post, which will show you where the blog post is. There's a blog on this already with the demo assets published, and we're just going to have the YouTube video and this presentation out there next. So this is everything we showed you. I showed you a minute ago. I leave the results in the database. Do-Hoon comes in with Oracle Application Express and shows some really nice interactive graphics. My favorite graph, a box plot. You can do just, you know, if you look at the different types, there's many different things here, but also, you know, Do-Hoon can do this stuff pretty well. And he's just recently learned it, you know, actually. I can do it a little bit as well, you know, which is kind of testimony to, you know, it's Application Express is what they call a low code sort of application. I don't have to write a whole lot of code and I get a lot of things to happen. But wait, there's even more. And so I don't know if you've noticed, but the Oracle Analytics Cloud development team, we've been working with them and they've done some really cool things lately. So now that I have some models inside the database, I, as an Analytics Cloud user, can do a few different things. I can just simply point at those results and graph them, but I can also go into here and I can register a model like this attrition support vector machine model or a fraud model or whatever. So I'm going to try and show you just a little bit of that here. Now, I'm mostly showing some results that I've already done, but I just want to show you there's some stuff by Philippe Leon and others that have been done out there. If I want to register a model, I can come into here and say, well, where's the model? And I have, where are my claims models right here? I don't want to do this again because I don't have this all set up to go down this path too much, but I was just doing the generalized linear model, and there's the input columns, there's the output columns. And if I just want to register this guy, I guess I could register him right now. It registers, and now that model becomes a model down here in these flows. And I have these data flows, which actually I guess I have done before. So let me show a little bit of this. I was just going to go straight to the graphs, but here's some claims data. Here's a model that I just used, and I can save the results, and there are my results and my predictions and my probabilities. So I can do a lot here, but what I wanted to do was just kind of focus on the graphs now. So I've already done a little bit of that, and we're kind of coming in towards a close. I just want to show you a few more cool things because there's so much you can do now with this converged database. I've taken, kind of like Do-Hoon has done as a more of an app that could be a mobile app or an application to thousands of people. I, as a different kind of analyst within this Gecko insurance company, I want to kind of look at this and do a little bit more interactive analysis. So I can come in here and say, well, you know, what's the marital status? What's the prediction? But I can also do things like this where I can say, where is it right here? So I can visualize this so you can see the police report. I can see the probability. This is really the main thing that we're doing right here, the probability. But I like this guy right here. If I can take the probability and make him the color, then now I see those things that are the most likely. The darkest ones are the ones that are the most likely, you know, strongest thing. But I'm not really interested in all of them. I'm interested mostly in the ones that are deemed to be zero, the anomalous ones. Those are the ones that really kind of leap out at me. And there they are. There's the two most anomalous ones. So if I want to like focus my energies today on like really tracking down some possible fraud, those are the ones to focus on. So people who know how to drive OAC, like Philippe Leon and all the OAC guys, Gabby and all those guys, they can do this way, way, way better than I can. Benjamin and all those guys. But I've just done a couple of simple kind of graphics. Here's another one where I have some table of data and some kind of graphic visualization here, and I can do filters and drill throughs and pivots and so on. I can do another kind of gratuitous graphic here of past number of claims based on vehicle price, maybe some past number of claims based on the number of previous claims past number of claims versus the probability. So they're all kind of similar. So that's kind of interesting, right? And I can do more exploratory graphs. Just want to kind of show you the ease and the beauty of having the data, the predictions, the analytics, the machine learning, all in sort of one converged place. It really is sort of like next gen kind of stuff. You can do a lot of things with it. So, oh yeah, finally back over here. I was going to take this, and I wanted to show. Remember, Do-Hoon was showing the prediction details. I think is what I was looking for here. Do I have prediction details? I could also add in here, down here in the prediction details. I could add in the prediction details in here somewhere. I'm not seeing it right here. Is prediction details. So if I put that in here somewhere, then I can also see for each person what are those reasons. Now this is a little bit cryptic, and the OAC guys are kind of working to make this a little bit more easily read, to parse out this JSON thing. But there are the reasons. Those are the rules, not a decision tree rule, but the what we call a prediction detail. The reasons why you would think that maybe why the algorithm thinks this record is maybe a little suspicious. So I can do all sorts of cool things. And as I'm sort of searching around to try and find where these fraudulent occurrences are happening and how I can stop them and save money and do well for the company, I have a lot of other things. One of my favorite things is the ability to do data brushing, right? So I can come through here and say, just for these kind of cars or these cars or these cars here, I can brush through the data and find those records. And to me, it just seems like a really, really powerful way to kind of solve my problem of trying to combat fraud with data-driven tools and weapons that I'm provided here, with all the Oracle stack. So that's that, kind of coming down for landing here in our whole session. And thank you for staying tuned, staying with us and watching this. We've used Oracle Analytics Cloud. We've identified those most suspicious claims in a more interactive way. We've seen some more. We've seen some more cool graphics. We've seen the brushing. That's kind of it, right? We've gone from beginning, middle to end to try and solve this complex problem of combating fraud. If you want to follow up with any of these things in the PowerPoint, and certainly if you just Google, there are a lot of different YouTube demos and so on. This one will be out in this YouTube channel here. You can click on the links. You can just Google Oracle Machine Learning videos, or maybe Charlie Berger put in there. We have hands-on labs with a blog. So there's a lot of different resources here. And with that, Do-Hoon and I would like to thank you for your time and attention listening to this. Oh yeah, one other thing. The results will be out, not the results, the blog is right here. So if you just simply Google Oracle Machine Learning, you'll see something that Do-Hoon and I wrote here, authors Charlie and Do-Hoon. And we've put all the results out here with, the different things. But we also have the, where is it, right here. The demo assets are on the Git, or I'm going to just click on it this way. They're out here in the Oracle Analytics and Data user community right over here. And we have this Oracle Analytics, the Oracle Analytics and Data user community, of which I'm a co-founder and very active with a bunch of other hardworking people. We try to share some stuff out there. We have a machine learning, we have analytics, different sort of subfolders, and you can come in here to the claims one, and you can download the notebooks that we did, the data sets, and we'll be putting, Do-Hoon will be putting his Apex application up there shortly. So anyway, that's how you get it if you want to follow up with that. And with that, I think that's it. Do-Hoon, anything else?
No, that's it. And yeah, thank you so much for your presentation, Charlie. I really enjoyed and appreciate all the hard work.
Likewise, great job. I'm gonna stop sharing and say thank you everyone who attended, and thank you for your time and enjoy the weekend. Take care.